Okay, one of the things you can do with an astrolabe is figure out when sunrise or sunset is going to occur. So to do that, first let's pick a date. So I'm going to pick October 2nd for reasons that'll become clear in a minute. So here's the calendar. October counts up this way. So there's that main line there is going to be October 1st. That's October 2nd. And you see, if you look at this ring here, I was trying to pick a number. There's 180, 190. Pick 190. That's sort of midday, I guess, in October 2nd, because that would be October 3rd right there, right? So that's October 2nd. So just shy of 190 on this ring here. So you go over to this side and you find 190 on this ecliptic. There's 180, there's 190. This line that goes all along here is the horizon. So we're going to spin this till the 190. If we really want to be careful, we'll just be just shy of it right there. Make sure that we're not having any parallax error. So we're there, 190. Just shy of 190 there. And then we spin this ruler just shy of 190 there. Let's see, put it right there, and then you read the clock. And it looks like it is, move this out of the way. So that, each of these is 5. So 6:10 would be there. Let's double check what we have here. So let me put my thumb on there to hold it. All right, so that's just shy of 190, touching the horizon. We line that up with that. And then we look here. It's a little hard to tell. So let's say 6 hours and 10 minutes. Maybe 6:11. Call it 6:10 for now. Let's check if that's right. All right, so I have a calendar with the sunrise and sunset. So the 2nd, and I had noticed you have to tell where you are because that obviously affects when sunrise and sunset is. So according to this, sunrise is 6:37, and we calculated 6:10. So, well, it doesn't seem broken. So why does this say 6:10 and the almanac says 6:37? Well, for one thing, the almanac is in clock time, not solar time. Solar time is at 12 noon in solar time, the sun is directly overhead. It can't be any higher. Clock time, noon is close to when the sun is overhead. There's a lot of other things going on. Mainly, keep in mind that clock time is basically a political construct made so that trains run on time, not necessarily accurate to astronomical observations where you are. So firstly, the first step is between 6:10 and 6:37, we're in daylight savings time. So we have to add an hour to this to make it match the clock time. So our 6:10 becomes 7:10, still not the same as 6:37, so something's wrong. Well, the other thing is where we are in the meridians. So we're on the East Coast. The meridian for the East Coast time zone is 75 degrees longitude, and we're at 70, so we're about 5 degrees to the right of it. What that means is the sun rises here sooner than it does when it's over the meridian of the time zone. So for every minute or for every degree different, it's 4 minutes different. So if we're at 70 and the meridian's at 75, that's 5 degrees different. 5 times 4 is 20, so we have to subtract 20 minutes from the solar time. So it was 6:10, we add an hour for daylight savings time, that's 7:10, and then we subtract 20 minutes and we get 6:40. So that's, no, I'm sorry, 6:50. So that's closer, right? So you got 6:10 plus an hour, 7:10. Take 20 minutes off of that to account for where we are, and that makes 6:50. Still not 6:37. There's one last step. The equation of time. There's with reasons I don't necessarily fully understand myself, but the orbit of the sun and Earth has got some wobble to it, and this kidney-shaped pattern accounts for that fudge factor to make up the difference. So let's go back to our date. What was it? It was October 2nd. So we'll go to October 2nd, and then you look at this, and you subtract, looks like 11 minutes because of where it is on this line. So we'll go back here. So again, we were at 6:10, add an hour, that's 7:10. Subtract 20 minutes for how more east we are, that's 6:50. And then you subtract 11 minutes for the equation of time, and that's 6:39. And the almanac said 6:37, so it's pretty close. It's about as accurate as you're going to get for an analog thing like this.